All right, so I got cut off at the very, very end, but basically I was just saying that in your y equals, you should unhighlight the first, the second, and then on the third line, you should put the in function, which was e of t minus L of t, so y1 minus y2. Keep that highlighted. Y equals the fourth equation, you should just be 0 because you're going to see when that intercepts the x-axis, because when do I have a maximum? When the first derivative equals 0 and I see a sign change from plus to minus. So then when I hit graph, this pops up, and I'm trying to see if you could, and so that pink is that in and out function, and the green is the 0. So you're seeing it goes from positive to negative. So it's your job to just go ahead and find the intersect of 5, get the cursor near it. If you're not sure where your cursor is because it's not in your window, this is 9, so this is 10, 11, 12. It's around 15, 16. So you get close, press enter 3 times, and then you get 15.794 or 15.795 is the time when the maximum occurs. They did not ask me what the maximum was. They said, when is the time? So you just answered the question. All right, so now we're going to move on to the second question, which will be the last question that I do with you. And this is 2013. So you should have that in front of you, and you should have read it, hopefully, or glanced at it. And it says basically that we have G of t that's being measured in tons per hour. So any important information, I really want you to always just get in the habit of writing down. G of t is tons, measured in tons per hour. I go ahead right now, I'm just going to clear my calculator, and I'm going to go ahead and plug in that equation. So you got 90 minus 45 cosine x squared over 18. All right, so that is my G of t is in y1. So then it goes on to say that t is measured in hours and the domain 0 to 8. So I know if I'm graphing anything right away, I'm going to change my window from 0 to 8. Okay. Then they say at the beginning of the work day, t equals 0, the plant has 500 tons of unprocessed gravel. Okay. Well, we should also say that G of t is the unprocessed gravel that arrives. So that's what G of t is representing, okay? And then they're giving us the initial condition. This is a rate. So if I went ahead and I integrated it, I would just be at tons, and it would tell me the tons of unprocessed that I have. So they're giving me the initial condition that if I was to integrate this, that at t equals 0, the plant has 500 tons of unprocessed gravel. Okay, then they go on to say that during the hours of operation 0 to 8, the plant processes gravel. So now this is another problem. This is saying the plant is now processing gravel at a constant rate of 100 tons per hour. So that's that's a constant, and this is a different function. Processing the gravel is happening at 100 tons per hour. Okay, so always have all your information written down, and then we can get started. Here they go ahead and say find G prime of 5, and then they say using the correct units. Well, this is why I like to write my information down. If I take the derivative, I'm going down that function Q, and since this was tons, this is now going to be tons per hour squared. So I know my answer is going to be tons per hour squared. And they say interpret your answer in the context of this problem. So literally, this is just you understanding how to manipulate the calculator. You have G of t in your calculator. You go to the home screen, and I'm just going to take the derivative. So math 8, and I'm going to put x here, vars, y1, and I don't want an x here. I want the value at 5. And so then I get 24. Hold on. All right, so I did a little pause there just because I realized that I did something wrong in the very beginning. All I did was I typed in a minus instead of a plus. So just if you listened to what I was saying, you should have put a plus there instead of a minus, but you guys probably were fine with that. So now when you go to the home screen to find that actual value of G prime of 5, I knew my answer was off because that it wasn't matching up with what I had gotten before. You just go to Math 8 and you go ahead, and at this time you should be fine and probably ahead of me with this, and you put your vars, and then here you put 5. And when you go ahead and get that, then your answer is negative 24.587 or negative 24.588. So now they're asking you to interpret your answer in the context of the problem. So you know that the rate, this is about the unprocessed gravel that's arriving to the plant. So I know the rate at which that the unprocessed gravel is arriving is decreasing. So the rate that the unprocessed gravel arrives, 2 R's there, arrives at the plant is decreasing by 24.588 tons per hour squared. Okay. All right, B. Now they say for part B to find the total amount of unprocessed gravel that arrives at the plant during the hours of operation. So they don't say anything about talking about, well, I have to consider how much of the unprocessed gravel was processed. So they just want the amount that was processed. So I go, okay, well, if that's the case, the total amount is from 0 to 8 that arrives is just going to be G of T. Okay, so that you're just going ahead and you're plugging that into your calculator. Math 9, 0 to 8 dx, and you're pressing enter. So hopefully your calculator is looking like mine and you're getting that 825.551 tons. Okay, now here comes a little bit where it becomes a little tricky. It says, is the amount of unprocessed gravel at the plant increasing or decreasing at T equals 4? Okay, so let's look at those words. Is the amount of unprocessed gravel at the plant increasing or decreasing? Well, then I just want to know the rate of the unprocessed gravel. So, well, the rate is here. G of T is the rate, and I want to know the rate at G of 5. So there's nothing for me to take the derivative of, because remember, this is the first derivative. So when I go ahead and I see that I just want to know what the value is at 5, I just go to my second table, I type in 5, and I get that the rate of the unprocessed gravel is 98.141 tons per hour. But we have, that's what the rate is at T equals 5 of the unprocessed gravel arriving. But now we have to take into consideration this piece where they said that, listen, the gravel is being processed at 100 tons per hour. And now they're saying that the arrival is happening at 98.141 tons per hour. Well, that tells me that this is less than the processed gravel. So what we're going to say is that because G of 5 is less than 100, which is the processed gravel, the amount of unprocessed gravel at the plant is decreasing at T equals 5. Okay. That one was a little tricky. You'd had to know to compare it to the fact that we had processed gravel. All right, now the last one, D. When we're working with D, they say, what is the maximum amount of unprocessed gravel at the plant during the hours of operation? Well, if they're talking about the max, first of all, I want to just think about how do I figure out the amount? Before I hear maximum and I right away get excited, I think I'm going to take the first derivative. But first I want to know, well, what is the function that's representing the amount of gravel? Okay, you know the amount of gravel at T, you know that we start off with 500 tons of unprocessed gravel at T equals 0. And then I know that I have to integrate the arriving of the unprocessed gravel. But remember, with the in versus the out will tell me the amount that's left, that is there, right? So G of X is the amount that's arriving, and minus 100 dx, well, that's going to be the processed gravel. So it's always with these problems, you're going to find the amount is in minus out is going to be the integrand. So here, this is the equation for the amount of gravel that is unprocessed at the plant. So now I want to just take the derivative for the maximum. So when I go to take the derivative, this 500 goes away, and now we have to do the derivative of an integral, so that's the second fundy. So the derivative of the upper bound is 1 times the upper bound subbed in to the whole integrand, guys, to the entire integrand. So T is getting plugged into G of T minus 100. So that's the derivative of the upper bound times the upper bound subbed in. Then technically it's minus the derivative of the lower bound, but the lower bound 0, so I don't need to continue. So A prime of T is equal to G of T minus 100. So that's going to tell me the derivative of the amount, and I want to set it equal to 0 and see if do I have a sign change from plus to minus. So if I take G of T minus 100 and set it equal to 0, I'm looking for when G of T is equal to 100. Well, that's easy. I'm just going to go ahead on my calculator and go to y equals, that's my G of T. My next line is going to be 100. My window for sure is going to be y max to be way more than 100. We'll make it 200. My window for x is from 0 to 8, and I go ahead and I hit graph. Trying for you guys to see that. So that's G of T, and then that horizontal line's 100. So I want to see where that point is, and it's going from up to down, so that's going to be a max, right? From plus to minus, that's a max. So I go ahead and I go second intersect 5, and I just move that cursor over to get close. And when I do that, my intersection of that graph, that point, is 4.923. So that is the time of my relative max, but this question was asking you for what was the max. So that tells me I need to find and take into consideration the endpoints of 0, 8, and now 4.923. So just because I'm running out of time on this video, I'm just going to tell you, you would plug in 500 plus 0t g of x minus 100 dt for each of these. And when you do that, you get that this is 500, this is 635.376, this is 525.55. And the question was, what was my maximum? So you will say the maximum amount of unprocessed gravel during the workday was 635.376 tons. That's the max. Okay, so good luck on the ones that you try, and we will go over it on Friday.